Good morning, good afternoon, or good evening, depending on where you are in the world. Welcome to today's DevOps.com webinar, brought to you by TechStrong, Splunk, and AWS. My name is Cody J. Brown, and I'm the host of TechStrong Learning. We have an exciting presentation ahead, but before we begin, I have just a few housekeeping notes. First, today's session is being recorded, so if you miss any of our discussion or you'd like to share it with a friend, the on-demand recording will be available shortly after the webinar concludes today. If you look on the right side of your screen, you'll notice the Q&A tab. That's where we want you to send in any questions that you have for our speakers today. We will try to address as many of the questions as we can toward the end of the webinar today, so be sure to send them in early so we know to leave enough time. Also, you'll find the chat tab right next to the Q&A tab, and this is where we want you to engage with one another, engage with us, or just let us know from where you're calling in. Today's slides can be downloaded by clicking the Handouts tab on the right side of the screen. And finally, at the conclusion of our webinar, we will have a drawing for 4 $25 Amazon gift cards. So on to our topic today. We will be discussing maximizing a cloud migration, a roundtable discussion with AWS and Splunk. And I'm joined today by Greg Leffler, Director of Observability Practitioner at Splunk, and Ranjit Kalidasan, Senior Solutions Architect at AWS. It's my pleasure at this point in time to turn the floor over to the two of them to get us started today.
Hey, thanks, Cody. As Cody said, I'm Greg. I'm here with Ranjit. I just wanted to give you a brief overview of what the session today is going to be about and the structure of the session. We're going to start with some prepared content from both of us. Ranjit will take the lead with some content from AWS about what a cloud migration is and how AWS can help you do that. And then I will talk about what observability is and how Splunk can help you get to that. Then at the end, like Cody said, we have a ton of time reserved for questions. We really want to hear from you about what you want to know from us. Right? Do you have questions about getting to the cloud, about using AWS, about using Splunk, about observability? So throughout the session, feel free to drop your questions into the Q&A, and we'll look forward to talking to you here in a little bit. But right now, I'm going to hand this over to Ranjit, and he's going to talk about what AWS has for you to help you start and maximize a cloud migration. Go ahead and take it away.
Thanks, Greg. Hello, everyone. My name is Ranjit Kalidasan. I'm a Senior Solutions Architect working for AWS. I am part of an ISV partner team for North America. So in my role, I work with strategic partners like Splunk to make sure that a partner is successfully using AWS services, and also our customers are successful in using partner products and solutions that are integrated with AWS. So in my session today, I'll be talking about migration and, most importantly, what customers can choose to modernize with AWS, right? What are the services and options and some of the patterns that we have observed in the field for modernization with AWS. So with that context, let me just get started, right? So we have experience migrating about thousands of servers and customers, into AWS cloud, and over the period of time, we have seen very key distinct patterns emerging as far as the decision making is concerned, right? And it is mostly aligned to the stakeholders for any enterprise, right? So if you take a very average sized large enterprise that has about 1,000+ apps, so we have different stakeholders and starts with the CIO. So CIO here wants the application portfolio mapping to business objectives, right? And from a CIO perspective, CIO want to first develop all the apps in-house. They want to migrate and modernize as much as apps to the new world, containers world. And also CIOs want to prioritize the use of a SaaS, right? So overall, the CIO's objectives align to how do they improve the customer experience, and also how do they improve the performance of the most critical business applications, right? Moving to the next quadrant, we have the CISO. So from the CISO who wants to map to the CIO's objective, it is a totally different world, right? Especially when you talk about the cloud first model. So here, the CISO's organization has to move away from managing traditional hardware security appliances into manage everything into the realm of cloud, right? So suddenly they are exposed to terms like organizations, IAMs, least required accesses, right? And how do they enforce that security controls to make sure that the data and the application stay secure in the cloud? right? And the second important driver we've observed, apart from the developer productivity, is the big data, right? The VP of the big data, from his perspective, suddenly there is a huge increase of data streams that needs to be processed. And the art of possible in cloud is immense, right? So they have so much of services and products. The VP of big data can use, like building a lake house architecture, a data lake architecture that can scale to the incoming data demand, and using completely cloud services to process enormous amount of data, right? And use an AI and ML services to work on this data and get values and insights from the data, right? And moving to the VP of Infra and Ops, right? And again, so this is a very challenging goal, because suddenly they are exposed to the new world where they have to start from reskilling their workforce to the cloud world, right? So they're moving from managing hardware appliances, storage, and physical infrastructure that are into the cloud. So how can they skill and bring that skills to their workforce? It starts with skilling, and then how can they leverage the cloud model for defining everything as an infrastructure as a code, kind of models that is there in the cloud to adapt to the cloud world, right? So there is a different stakeholders and different requirements that we have observed over the period of time. So why AWS? Why customers migrate to AWS, right? Because we have the most migrations experience as far as any public cloud is concerned, right? So we have over the period of years, we have helped customers to migrate many workloads of many different size and scale complexities into the cloud, right? And we have a very broad ecosystem, partner ecosystem, where we work with a lot of technology partners, ISV partners, and SI partners, and we built a most comprehensive and best methodology for helping customers migrating into the cloud, right? With a complete data-driven and automation guidance approach. So we have developed the processes that reduce the complexity of migrating the workloads into the cloud. So this helps customers to expedite or accelerate the migration phase into migrating the workloads into the cloud. So if you look at the modern application development, right, it addresses, and especially in cloud, it addresses a lot of challenges the traditional legacy world, right? Starting from developers waiting weeks and days to get the infrastructure. So now everything can be provisioned as infrastructure as a code, right? They don't have to wait for any resources. Developers can avail any resources on demand, right? And earlier software used to be manually deployed on ad hoc basis. Now we have a DevOps operating model, DevOps culture. The software is deployed over a continuous delivery pipelines and continuous build and test processes. Right? And earlier security is usually an after topic of an application deployed in the cloud, but now we can have the models, especially DevSecOps kind of a model, so that you can include security in each and every elements of this life cycle, and to make sure that starting from developing the code and testing and deployment, you have that security is inbuilt into that model, right? And earlier developer lack visibility of the applications running into the production, but right now we have a number of tools which can help instrument those applications, provide a very comprehensive view to the developers. And this is where partners like Splunk provides a major role in providing those comprehensive solutions to the customers. So now, looking at the benefits of modernization with AWS Cloud, right? And this is the result of a survey that IDC did with some of our customers who had been using our serverless platforms for about 5 years, right? The results have been very staggering. First of all, they got the payback within 9 months, right? Which has been very rare in the industry, right? And they were able to get 4x ROI over 5 years. The reason they were able to get that much of ROI is because they don't have to maintain any underlying infrastructure. They don't have to maintain cycles of time to go and focus on scaling the application infrastructure. So everything is inbuilt for them with the serverless compute and container services that we have, right? And also this modernization helps customers to reduce the number of security incidents per year, and help developers with a faster compute and deployment time. So overall, from my modernization's perspective, so we have three major approaches that has emerged, right? First is customers wanted to, if they want to re-architect or refactor the existing application, they want to modernize and look at the container services, right, as a primary, the mode of migration, right? And also, if the customers want to build something as a new, they want to leverage the serverless models or serverless solution that AWS offers, like Lambda or API Gateway or serverless databases like Aurora Serverless, right, to build a complete serverless model so that they just focus on the business and application. The rest, everything is handled by AWS in terms of, especially in terms of scaling and also making sure that applications are highly available, right? And overall, they have to adopt a very agile model, lifecycle model, and that's where the customers have to adopt a DevOps kind of a lifecycle and model for this modernization efforts. So what do we offer in that space, right? So right from infrastructure to a complete serverless model, so we have a many different choices we provide to the customers. If from an infrastructure perspective, we have a number of EC2 instances that customers can use to build their modern application and platform on their infrastructure so that they have a complete control and management. But if customers want to just focus on the platform, they don't want to maintain the underlying infrastructure, they can choose services like Amazon ECS Elastic Container Service or EKS Elastic Kubernetes Service, which is a container management as a service. It provides a platform for the customers where they define the infrastructure and they use that orchestration solution that we offer with those services to orchestrate and automate those the deployment of their applications, right? But if the customers have to move further and they don't want to manage any underlying infrastructure, they can go and leverage AWS Fargate, right? With Fargate, you just mentioned that Fargate is going to manage the underlying infrastructure, then you just focus on the platform. So we are going to make sure that infrastructure is available and the infrastructure is scaled based on the demand of the application, right? At the top of the abstraction layer, we have a serverless solutions like Lambda, where customers only focus on dropping their application code, and we are going to manage the scalability and availability of that application, ensure that it scales to the demand for that application, right? And recently, we also released a feature with Lambda where customers can drop container image instead of the traditional application code. So, and also very important is a DevOps lifecycle model and culture. So I'm here talking in DevOps.com, so I don't want to preach to the choir. Everyone knows about the DevOps model, right? But then it then starts with the right from authoring and providing the right tools for customers to author their code, save their code. So we have we provide SDEs and SDKs for customers. Then store the code. So we have a source and artifact products like code artifact or ECR public and code commit repo. Then doing building and unit testing, we have a AWS code build, and for continuous deployment, customers can use code deploy. And finally, to monitor the overall CI/CD model, so customers, we have many tools, and customers also not limited with these tools, right? Customers can bring their own tools or some third-party tools to integrate into this model, right? For example, for the code source, so customers can use GitHub or GitOps or GitLab, whichever is comfortable. Like they can have Jenkins instead of code deploy, and they can use a Splunk, and we're going to see what Splunk has to offer in this space to provide instrumentation for this the DevOps lifecycle. So this is all good, and we are talking about a lot of services that AWS offers, right? So what's the best starting point for customers, right? Because customers are looking for an opinionated stack or a kind of a template to start. So that's why we have a shared service platforms. Shared service platforms provide a consistent tooling, governance, and guardrail to the customers, right? So from a containers perspective, so we have AWS Copilot, which is a shared service platform for ECS service, which is based on a CLI model. And we have a Kubernetes SSP blueprint, which is for EKS, the containers the customers can use for EKS deployment. And we have Proton, which is just a for which customers can use the container code and also the serverless model, like using Lambda. They can deploy their application using AWS Proton, which is going to deploy all the underlying stack for the customers, including the CI/CD stack and the entire life cycle for deploying those apps, deploying and managing those apps. So just to finally to summarize what we have, what I've discussed so far is right. There's a different approaches for modernizations. If customers want to build new and cloud native, so there is serverless based approach, an event driven architecture customers can leverage, and also customers can leverage purpose built databases. While I haven't touched so much of databases services, but we do have, depending on the use cases for AWS, we have so much of databases that we have, like NoSQL databases, RDBMS databases, graph databases, timestream databases, right? Customers can use that. From a re-platform or re-architect perspective, customers can look at our containers, managed container services like ECS and EKS, and use our shared services platform as a starting point for deployment. Thanks for listening to me, and now let me hand it over to Jeff to learn what Splunk has to offer from observability and monitoring space. Okay.
Okay, thank you. So I just want to remind everybody before we jump into this, right? We are going to have a lot of time at the end for questions and answers. Please go ahead and start throwing those into the Q&A box you see up on the screen. And also, not to make the screen too busy, but I do have a little question before I really jump into the content about observability, which is what I'm going to talk about for a little bit here. How important do you think observability is to your business right now? And there's not a right answer here. I just really want to see how people have heard about observability, if you think it's important, if you think it's useful. So if you want to answer, the poll should be in the corner of your screen. And I'll give everybody a second to do that while I talk about what's on the screen. So observability and cloud migrations are really sort of interrelated, right? You need to have observability when you migrate to the cloud. There are a lot of services that make doing this job easier than it has been in the past, but a cloud native application is going to be significantly more complicated than a monolithic application in general, right? And so if you look at what's on the screen right now, you'll see a hypothetical airline could be having several different clients that need to access the same application. So you have kiosks at the airport where you check in and get your ticket and that sort of thing. You have the online boarding system or the online booking system where you actually make your reservations and pay for the tickets. You have the mobile app, which also needs to display your boarding pass and do that sort of stuff. And all of these services need to interact with the airline application, which in a cloud-first model is split up into a lot of microservices, right? So you see in this case, we have the Java app that handles baggage. You have a Miles loyalty application. You have a flight status service that probably talks to some mainframe. You have a checkout microservice. You have a boarding pass generation service. And all of these things could be hosted in different environments. They could be different languages. They could be serverless. They could be running on infrastructure as a service. They could be running in EKS or something like that. So what I'm saying here, right, is that applications are very complicated, and to figure out what's going on with them, you need to have something that can help cut through that complexity. If I look at the survey results, almost everybody said somewhat or very important. I hope by the end of this presentation, you'll think it's extremely important. But as you migrate into the cloud, I think one of the things that you'll start to discover is it's difficult to figure out where things are going wrong, right? It's easy to find out there's a problem, but where the problem is, sometimes it's more challenging to resolve. And if we think about monitoring a complicated application, our really traditional monitoring tools sort of amplify this complexity. They make it even more difficult to figure out what's going on, right? You have a lot of tools that only look at one particular thing, right? They have their silo for data that they investigate. They help break up sort of the visibility of your architecture. You can't see an overall view of what's going on everywhere because your traditional monitoring tools look at logs on your on-premise app, right? Or they look at, if you have an APM system, right, it only looks at your cloud-based stuff. It's not integrated with the rest of your application. There's also, as modern applications are deployed, they are more difficult to fix and they're more difficult to find where the problems are. So this leads to higher MTTRs and difficulty scaling your application and scaling your observability / monitoring world, right? These are both things that are really important and things that you really want to be able to pay attention to as you're building your cloud application and doing that migration work. So we talked about, I talked about observability, and people always ask me like, hey, how is this different from monitoring, right? This seems like it's exactly the same thing as monitoring. And really the answer is that Observability is an evolution of monitoring. It's not replacing monitoring. We're not saying you need to get rid of monitoring. You still need monitoring, right? Monitoring is set up for things that you know can fail. If you know something has the chance to go wrong, you should monitor it so that when it fails, you can figure that out and you can address it. Monitoring traditionally is associated with point tools. You have a tool that monitors one aspect of your business or your application. Observability tries to integrate all of your data into one place. So you can see across wherever your app is hosted, whatever language it's written in, however it's end user facing, or it's a front end or a mid-tier or your database, right? That you can get all those answers in one place. Monitoring also is putting data on the screen. It's saying, here are some metrics, bam, there they are. Here's some green squares, yellow squares, right? This is what's going on. Observability is about helping you get answers. It's about helping you figure out what has gone wrong fast. Right? It doesn't just show you every single piece of data, because if it did, you wouldn't be able to understand any of it. There would just be too much to even deal with. So observability includes elements of AI ops and ML to help you figure out, okay, given this change in these metrics, what is likely the underlying problem? And monitoring systems generally are, like we said, they're point tools, but they're also sort of ad hoc and siloed, right? Monitoring only monitors what you tell it to. They can't go back later and say, oh, what was this doing back when this thing broke, unless you were monitoring it to start with. In an observability practice, right, you want to try to monitor literally everything that can be monitored, and then your observability tool helps make sense of all that data. The advantage of this, though, is that you do have all of that data. So you can later go back and say, oh, hey, what happened to my Kubernetes master back when this outage occurred, right? If you weren't instrumenting every metric beforehand with a monitoring system, you don't know, right? But with an observability system, you can. So monitoring, observability, the cloud, doing a cloud migration are all sort of interrelated in our opinion. So if we think about what do you need for observability, well, the center of this graphic is what most people will tell you, right? If you ask somebody on the street, hey, what's observability? Well, on the street, they're probably not going to know. But if you ask someone in the audience, what's observability? They will probably tell you, well, it's metrics, traces, and logs. And that's true-ish. What metrics, traces, and logs are the data elements of observability. But just having metrics, traces, and logs isn't sufficient to actually have observability, right? You just have the data. Observability is doing stuff with that data, and it's doing stuff in a particular way, right? One of the strengths that we have at Splunk is that our observability system is built from the ground up primarily for cloud native applications. So we do, of course, let you monitor anything anywhere, but all of our observability tools were written for the cloud, cloud first, to really help you figure out what can the cloud do for me. We think that an observability system has to have these four things that are around the center of this circle, right? It has to be full fidelity. You have to be able to see what's going on in your entire application. So from the front end to the back end, from the user all the way through to when the transaction's committed in the database, or if you're a physical place, like when you ship the user the widget, like we want to be able to keep track of all of that. We also think it's really important that it be full fidelity, that we don't throw any data away. We don't sample. We don't say, oh, we're only going to give you some of it, right? We want to be able to keep all of the data because as any of you who have ever troubleshot things for a living know, right? Like it's the one thing that didn't get caught that's going to cause you problems. And I can't count how many times I've found some really weird one-off thing that, might have been thrown away. If we're only taking every 10th request, right? That could really amplify the time it takes you to find and solve a problem. Analytics powered and real time are kind of two sides of the same coin. In a modern cloud architecture, right, infrastructure comes and goes in seconds. If you're running serverless functions, their average runtime is about 600 milliseconds, so less than a second, and that instance has vanished, right? So if you're getting alerts that things are going wrong in like a 10-minute roll-up later on down the line, that's worthless. You can't do anything with that, right? You have to have something that tells you immediately, hey, this is going outside of your parameters, or based on how this metric is trending, it's likely about to cause problems, right? And then you need the analytics to help you make sense of all the data points, right? If you instrument literally everything, which is what we suggest you do, you can't make sense of it yourself. There would be just an avalanche of data, and you really need to be able to see for yourself what is important, what is the thing that matters out of this. We also think an observability system needs to be scalable. There are lots of observability APM platforms that just can't keep up with a large installation. And in a microservice universe, like every piece of functionality you add is going to add one or more microservices. And you're really quickly going to discover that to have a good observability system, your platform needs to be able to handle that. And it also needs to be able to handle things hosted in different ways across different technologies, right? Ranjit told you Amazon has 4 categories, right? They have Lambda, Fargate, EKS, and EC2. We can observe all of those, right? But like as you start to use more of that functionality, a lot of other tools can't do that. So we think something being scalable is vital. And last but absolutely not least is OpenTelemetry. There are a lot of observability companies that will say, oh, just download our magic agent and install it and everything works great, which can sort of be true depending on what kind of applications you're running and what language they're in and all that stuff. But really, any sort of observability instrumentation project is going to be work. You're going to have to know how your app operates. You're going to have to know what is important so that you can emit, hey, this is a customer starting a transaction. This is a customer finishing. Like there's no agent that can magically figure that out for you. So since you have to do this work, our opinion is it's very important that you only do that work one time, right? We're DevOps folks. We don't want to do toil. We want to do stuff that adds automation, that adds value. So OpenTelemetry is, yeah, you got to do the work, but you do the work once, and then you can take your telemetry package anywhere. You can write a self-hosted thing. You can run open source projects. You can use a commercial product, please buy Splunk, right? You can do any of those things, but you can do that on your terms, right? It's your data. You're not locked into somebody's proprietary agent and proprietary format. OpenTelemetry is the future for this. So we think it's really important that if you're thinking about observability, which you kind of have to be if you're thinking about doing a cloud migration, that you're thinking about doing it in an open way and using OpenTelemetry. So what is the solution that Splunk has for you for all of these things? Well, it's called Splunk Observability Cloud. It meets all of those things that we put out on the last slide. It'd be pretty bad of me as a marketing person to not have those things met, but it does cover all the things that we talked about. We give you full stack end-to-end visibility. We have powerful analytics. You can use signal flow to do custom manipulation to data coming in real time. We are enterprise grade. We can scale. We have customers that send us on the order of petabytes an hour of metrics, traces, and logs. So, even if you suddenly wake up tomorrow and you're Google, like we can handle that. And of course, we are OpenTelemetry native, right? All of the applications in the observability suite are OpenTelemetry native. We don't have proprietary formats. We don't have proprietary agents. It's all open. It's all yours. What I didn't put on this slide was the URL for the product, which I probably should have. So I'm going to put it in the chat. It's just splunk.com/Ollie, the letter O, the number 1, and Y. Observability has 11 letters in between the O and the Y. So that's why we say O11Y or Ollie. I didn't make up that, but that's what it is. So check it out if you would like. There's also a demo there so you can see what we're doing. What are the components of our observability product? And most observability products are going to give you most of these things. And they're really things that you're going to need no matter who you go with. And we'll sort of go around this diagram. All of these components do work together. One of the advantages of Splunk's observability product is that they're all in one user interface. So you only need to learn it once, and you can send links to other participants in your troubleshooting process or your on-call process directly to whatever you're viewing. And those people don't need to learn new tools. They don't need to worry about, oh, do I have access to APM today because we're using a different platform, or it's not integrated with the rest of our user accounts or that sort of thing. So these are the primary components. The ones in the center are the most primary, right? Infrastructure monitoring, APM, logs, and synthetics are probably the things that really are like the keystone parts of an observability practice. On-call and RUM are also important, and we'll talk a little bit about each one of these right now. So if we think about what's on the screen right now, this is APM, and specifically this is what's called a service map. Our service map is generated automatically. You don't have to tell us what services talk to what services. This helps you find a problem pretty much instantly as soon as it happens, right? You can see on this example, there's these little red dots inside of the services. The solid red square in this service up here at the top tells you this is where the problem is. This is the root cause of these errors that are earlier up in the stack, where you have this sort of red line running between two of the other services, right? This data is all generated automatically. we detect the patterns, we detect the problems and show you where they are. And we can even suggest, hey, it may be related to this change in this metric. That could be where you should start investigating, right? And that's all provided out of the box in APM. This is enabled through tracing, which is, like I said, it's instrumenting your applications to say, hey, this application is about to call this other application. And the tracing idea is that you can figure out, okay, which applications are talking to what other applications. And when there's a problem, you can find out where it is. You can also then see, all right, for this application that is having problems, show me based on what version of the code is running, what the problem rates look like, or based on the user class that it is, right? Or they're high value users, are they new users? Are they people who are logged in, or the people who aren't? Is this my blue deployment or my green deployment? Like, all of those things can be answered, again, pretty much instantly with APM. So we really think APM is like the flagship product of observability, and it really gives you the most value and helps you figure out where things are going wrong, right? In a modern model, as Ranjit said, they have customers that deploy to AWS 50 times an hour, and each one of those deploys could add a new service that talks to some other service, and you have no idea that that's happening necessarily, right? In an organization of that complexity, you don't necessarily know that's going on. So that can create problems, and you need to be able to find them right away and go, oh, it's this new service that's calling me for some reason, right? Like, that's over my load budget, or that's making me exceed my error budgets, right? Like, these are all things that you're going to want to be able to see, and APM shows you all of that. This is our infrastructure monitoring, and one of the things that we really like about this is obviously it does all the regular infrastructure monitoring you would expect, right? The memory, disk, CPU, network bandwidth, all that stuff. But we also can look inside of your Kubernetes environment, right? We can see, all right, for this node, which pods is it running, what's their status, what are their resource limits, all that sort of thing. We also can estimate costs for you, and we can say, all right, look, over your entire Amazon world, this is how many EC2 instances you have, for example. This is how much you've paid for them. And if you were to, say, switch to reserved instances, this is how much money you could save. One of the things that people often do when they go to the cloud is they just say, I want to get in the cloud because I want all these benefits that Ranjit talked about, right? But you really have to be clever is not really the right word, but you have to be thoughtful about what you do and how you do it. If you just take your existing application as it is and toss it up in the cloud, like, you're not going to get any cost benefits. You're not going to get any scale benefits, right? A infrastructure as a service provider is going to have to charge as much as you were paying for the infrastructure generally, plus they have to make some money out of it, right? So, like, if you just take your existing app and make no changes and throw it up there, you're going to have problems. So you really want to have a tool that can help you figure out, where am I spending money? How could I spend less and still make sure I have all these benefits, right? If you have this monolithic app that you throw up in the cloud, it can't scale magically, right? The scale benefits come from you being able to say, hey, this service is getting hammered. Let's scale up more of that service. If the service is your entire app, you're probably going to have some problems. So IAM is also important, of course, so that you can figure out what's going on in your Kubernetes environments, in your overall infrastructure, how much it's costing you, how much it's working, all that sort of stuff. We also talk about needing to be open telemetry native. I think I discussed this enough before, right? We use a single agent. It's open standards. It covers metrics, traces, and logs. You own your data. You can also directly connect to a lot of providers, including AWS, to get data out of their event streams, to CloudWatch and things like that, and figure out what's going on there. Splunk is the market leader in observability. We are the top-ranked vendor. We were the only outperformer in the latest GigaOM radar for cloud observability. We have beat out Datadog, New Relic, and Dynatrace. We handle scale. We have good analytics. We have open telemetry support, right? This is really something where you're not going to go wrong with using our product, but beyond our products, like doing a cloud migration, you need observability, right? And I realized we didn't talk about synthetics or RUM. These are really important parts of an observability system as well. RUM lets you see what's going on in a user's browser, right? If you look at a modern application, only some of it runs in the backend that you can control, right? Some of it is you're going to send a bunch of JavaScript down to the client, and the client needs to run it. You're also going to send in third-party libraries and frameworks and Google Analytics, Angular, whatever JavaScript front end you're using, right? That information all is going to come from someone else too. And you need to be able to see for each user, hey, did this work, right? Did it render properly? Did they get the resource in time? How is it doing for our core web vitals, right? Is the site fast enough? Do people experience that it looks good and works good? These are all things that Synthetics and Rum can tell you about, right? Rum is doing this on real user browsers. Synthetics is basically Rum with fake users, right? You say, I want a pretend user to do these things, and you can see before their problems, right? If the test user can't put an item in the cart and check out, you can see that before your users start to tell you about it. So Synthetics and Rum are also very important components of observability. And then the last one that I think a lot of people don't really think about is an on-call solution. Being on call sucks. I was an SRE for many years before I came to work at Splunk, and being on call is like the worst thing ever. And having a bad on call tool just makes it feel even worse. So, having a good on call system that's integrated with the rest of your observability platform, where you can see it thinks and says like, hey, this alert is firing. It might be because of this deployment that just ran, or it might be because of this new surge of traffic from service X. Like that can make things a lot easier. So I think it's part of observability, even though a lot of people maybe don't, but I think it is. So the last slide that we have here is just telling you like observability needs to have all of these things. You need synthetics, you need Rum, you need on-call incident response, you need log analysis, you need APM and IM. Like these things are all important to figuring out what's going on in the cloud and really making it something that is useful and that works, right? Ideally, right, you would want to be able to monitor your architecture wherever it is. Like, yes, you should move all of your stuff to the cloud. Yes, you should figure out how to take advantage of those benefits. But realistically, like you're probably going to have some stuff that it doesn't make economic sense or can't be re-architected well enough to go to the cloud for a while. So you need something that integrates the monitoring from what's on the cloud to what's not, right? If you're running something on premise, if you're running something in several different clouds, right, you need to be able to figure out how do I see what's going on across all of those, right? Like AWS, of course, provides you with things to figure out how your AWS applications are performing, but they don't necessarily want you to know in one pane of glass what's going on if you have stuff in GCP, for example. So we want to make sure that if you think about observability, use the tools that your cloud provider gives you, but you also may need to extend those with something that can look outside or that can look at your on-premise things. So this is the end of our slide content. We do have a lot of time left in the session, and we're hoping for questions from you about observability, about AWS, about the cloud, just anything that you would like to know. Please go ahead and throw those in the Q&A box, and we would really enjoy hearing from you. So we'll see if there are any questions here in just a second. Well, it looks like we have one asking, what about logs? Because I didn't talk about logs, and I'm from Splunk, which is true. I didn't talk about logs. Logs are obviously an important part of figuring out what's going on in the cloud. You sort of need to know what has happened when you are solving a problem, right? We view metrics, traces, and logs as sort of a what, where, that there is a problem are your metrics, where the problem is are traces, and then what the problem is in your logs. You need to have all those things. The Splunk you probably think of when you hear the name Splunk is our Splunk Enterprise or Splunk Cloud product, which can monitor observability or can provide you with some observability features. It can monitor some cloud workloads, but it's not really built to do that, right? And so in our observability suite, we have a product called Log Observer, which is sort of a mini Splunk log analyzer inside of our product. And it doesn't require you to learn SPL. It supports regular expressions. It's really sort of developer, engineer, SRE friendly. And so that's what our log answer is for observability. I don't see any other questions right now. If you have questions, we've got answers. Please feel free to throw them in. Wow. Okay. Ranjit, is there anything else you wanted to talk about a cloud migration, about AWS? Anything else that's on your mind? I still don't see any questions right now.
Not much, Greg. Just to add a point on the logs that you mentioned, right? So with AWS and Splunk, right, we have very tight integration with both of our products, and currently customers can send any type of machine data, AWS machine data, into Splunk, right? There are different solutions and solution patterns are available, and typically we talk about sending logs and events to Splunk, and we have Kinesis Firehose, which supports Splunk as one of the destinations, Splunk Enterprise, Splunk Cloud. The customers currently used to send volume of log data into Splunk. They can also use Lambda functions to send data into the Splunk, log data into the Splunk, and also CloudWatch. Amazon Event Bridge is a service that collect events from different services and send those events in real time. And Splunk is one of the destination. The customers can configure Splunk Hack endpoint as a destination to send the events. Right? So just want to add that in points.
Yeah, definitely true. We do have a question. If I used AKS and EKS, how would I add this to my Kubernetes cluster and containers? So, Stephen, I'm not sure I fully understand the question. Oh, I see. If you wanted to use them across Azure and AWS at the same time. I don't believe it would be recommended to try to build one Kubernetes cluster across the two environments. I imagine you could probably hammer it together. I mean, I could think of some ways you would do that, but realistically, you would probably need to architect your app so that some of it lived in Azure and some of it lived in AWS, and then you could split up which services you ran in which, or even just duplicate the application and route some traffic to which, depending on your application's need or cost or whatever you want it to do. So I guess I'll try to guess. Are you talking about observability across two worlds? Because that's pretty straightforward, at least in Splunk's tool, right? You could just give us credentials to, or access tokens to both of those environments, and we can pull data down from both of them and show you them in one place. But like, as long as you've instrumented your application, we don't particularly care where it's coming from. So that's one of the strengths of Splunk's product, is that you can send us stuff from any cloud vendor, from on-premise, anything like that. All right, we'll give it just another minute or so for questions. And then Cody, if you want to hop back on, we can give people back a little bit of time if we don't have questions. All right, Cody, let's give away some money.
That's what we all like to hear. Thank you. So real quick, our 4 winners of our $25 Amazon gift card drawing. Our first winner is Yuval S. Our second winner is Dinesh Kumar A. Our third winner is Kanhaya M. And our fourth winner is David C. Congratulations. Keep an eye on your inbox to claim that gift card. And if you don't receive an email, just check your spam folder. I would also like to remind our audience that today's session was recorded. You'll receive an email shortly after we conclude the webinar with a link to access the on-demand or you can find it living on the DevOps website. Just visit devops.com/webinars. So Greg and Ranjit, I'm looking through and I'm not seeing any more questions at this point. Is there anything that you want to, any final departing messages before we wrap up today?
Greg, you can go first.
Okay. No, I would just say that like moving to the cloud has a lot of benefits. AWS is definitely one of the leading providers, probably the leading provider. They have a lot of things that they're going to offer for you. And to really get the best value out of it, we think observability is important. And so do they. That's why we did this webinar together. If you have questions about how to do this, like reach out to your sales engineers at AWS, reach out to them at Splunk. Like we have a whole teams that can help you figure out like, hey, how do I do this the right way? And how do I make sure I can still run my application? So we just encourage you to learn more about it, dig in, answer any of those questions you have, and just play with it. It's fun to do this kind of stuff. Like the power you have access to is unimaginable, right? And so just read up on it and really enjoy it.
Yeah, just from my perspective, just adding to what Greg mentioned, yeah, AWS offers a lot of services and features for customers, right? And the reason we continue to innovate in our services and features is what we listen from customers, what customers really ask, right? So there is the container space is also a ever-growing space, and I remember we have released a lot of features and services in the last reinvent. Please do check on them, and if you have any more feedback on our products and services, please reach out to your AWS counterparts, and we'll be happy to listen to you and make sure that you get what best out of from our services.
Wonderful. Well, thank you so much, Greg and Ranjit, for taking the time to be here with us, to share your expertise across your two various fields of experience. So I really appreciate you taking the time to be here with us today. I'd like to thank Splunk and AWS for sponsoring today's webinar. And my final thanks, of course, goes to you, our audience. We appreciate you being here with us. Please take a moment to fill out our post-webinar survey, and we hope to see you at a future Tech Strong Learning webinar. This is Cody J. Brown signing off.